Hi, welcome to the 25th rule of acquisition, the locality tell. The reason why we're doing this instead of our normal sequence of videos is because I did not realize I hadn't produced this video yet. And it really should have come out before the video announcing new Electromagnetism V5 results. However, that actually works out for the best because in that video I referenced the 25th rule of acquisition. And so what I'm going to do in this video is add that material in so you can see why that classical electromagnetism fails the locality tell. Okay, the locality tell is one of the very first rules of acquisition. It was instrumental in recognizing that classical magnetic field models could not be the correct models for magnetism. Okay, now the reason why we have the rules of acquisition is, if you remember that video, we had many different models that gave excellent results for different experiments. And so if we only had, let's say, these experiments here, and all the simulation results match all the experimental results, you'd say, well, gee, which is the right model? I mean, there can only be one model that matches how nature does stuff better than any other model. And so one of the methods is just keep running experiments until you can knock the ones out that don't follow nature. Okay, that's called disambiguation. Okay, but you still may run into the situation where you have two models left over that still give you experimentally accurate results. And so you need some other means to be able to say, hey, which one is it? Or more importantly, if you have a model that fits nature and you only have one, you need other checks. I mean, it might give you experimentally accurate results, but how do you know it's the right one? There might be another one out there that you're not aware of yet. Okay, and so science had this rule of acquisition many, many years ago, they would have found out a long time ago that a lot of the stuff that we have in modern science is garbage. And actually, it turns out they did have this many years ago. We'll cover that. But they castrated it. And Albert Einstein has a diabolical role in that. Now, let's go back. We're going to get into this later, but let's go back. Because remember the wire experiments we did, we had to correct classical magnetism. Because classical magnetism only considers the velocity of the target charge. That's what T stands for. The force on the target charge is the quantity of the target charge times the velocity of the target charge across the B field at the location, the locality of the target charge. Okay, but they don't consider the B field velocity here. So we updated it here. But then what we did is we went on and said, well, the only way from the locality, and we'll go cover locality in more detail, the only way that you could have the only information you have at each individual point charge that's creating the source field is the velocity of the source field. And so this is what we ended up as the corrected form of classical electromagnetic theory. Now, what I mentioned in that video, which is trailer video number 21, and I'll have a link for it later, is that there is another way of running the classical magnetic field where you can get the right answer. And instead of me trying to explain this here, we're going to explain this here. We're going to have some good diagrams coming up. Okay. Oops. No, I didn't want to do that right now. Okay. So I discussed what the rules of acquisition are. Okay. They're rules that help us look at a model and say, is this really the truth, or is there some other way we can judge a model or theory to know if there's something better else out there? Okay, so that's what I just did. Then we're going to generally describe what the locality tell is, and then we're going to show how classical magnetism fails the locality tell. And then we're going to go into a little bit of history and the misdeeds of Albert Einstein, which must have cost physics at least a century. And then we're going to show you what the predictions of the theory of everything are with regard to the locality tell. And then I'm going to do my normal begging and pleading routine for asking for help for Patreon members and all that stuff. Okay, we just discussed all that. So now what the locality says is all physics is reducible to a collection of emissions and coupling events. And all events are two-body in nature and are governed by the properties at the location, that's where the word locality comes from, of the event. Okay, and nowhere else. In other words, the emission, the wake of this boat comes from the properties of where the boat meets the water, and has to do with the velocity, acceleration and position of the boat, and the velocity and the position and the acceleration of the water. It has nothing to do. It has nothing to do with this boat over here. It has nothing to do with this boat over here. It has nothing to do with this point of land. So this emission is solely, and this has nothing to do with it. And so therefore, all of the properties at the location, at the locality where the boat is speeding through the water is the only information that can be used to figure out what these waves are going to do. Okay? And that's what I just said. And the next part is, now, because these waves are propagating, okay, their propagation is to do with the water crashing into water and nothing else. How these waves propagate has to do with the velocity, acceleration, the pressure, the temperature, the density of the water. And then when I say the elements, the water elements, what I'm saying is we don't have to actually go all the way down to the level of the water atom to get a good model for how waves propagate. We can actually go down to differential volumes containing water. And that's called finite element modeling. So that's why I'm using the term elements here with quotes around it. So we don't have to go all the way down to the atom to get good simulation results that match nature very well. Okay, now waves can also couple energy to other objects. So when these waves propagate, they're going to hit this boat, and the boat may rock a little bit. The waves might hit up against this little piece of outcropping of land here and erode the land, or yada, yada, yada. And it works the same principle. The energy from the wave crashing into the outcropping of land and all that, all the properties of that, when they interface each other, all the properties available at that interface is what governs that interaction and nothing else. Not this boat has anything to do with it, unless, of course, there's a reflection that comes across, but then you're just going to have overlapping waves that hit this. Okay, it's still the properties at the location. Now, about 1999 is when I came up with the locality tell, but I didn't call it that. In 2001, I called it the mechanism rule. A conveyor of an effect, field particle, and the receiver of an effect must exchange the effect within the boundary of the differential used to compute the total effect. Yada, 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 yada. So I called it the mechanism rule because it has to be a little mechanism how the energy transfers. But I didn't really like that. And then I developed, then I renamed it later to the missing link tell. You know, if you're missing some information, and I didn't really like that. And then the disconnection tell, never liked any of those names. Okay, then later, in about 2015, I was watching a video about physics paradoxes, and they mentioned the principle of locality. I was dumbfounded. They had this all the time. Okay, so this article is about the principle of, in physics, the principle of locality states that an object is directly influenced only by its immediate surroundings. Okay, a theory that includes a principle is said to be a local theory. So that's what it is. I'm like, well, wait a minute, hold on. You mean they had this? They already had. I had no idea they had this. I went through scientific philosophy in college, and maybe I was out that day. Okay, and I'm like dumbfounded. How is this even here? Why are we still holding on to this garbage physics we have? I mean, why weren't they applying this? They would have instantly have recognized that classical magnetic field theory is gibberish, Maxwell's equations are gibberish, quantum entanglement, violates locality. I'm like, what the hell's going on here? And then I thought, well, now I smell a rat. Because in 1935, Albert Einstein and a couple other idiots in their EPR paradox, theorized that quantum mechanics might not be a local theory. Oh, well, local theory applies to someone else, but it doesn't have to apply to you. So what the heck are laws of nature if they don't apply to everything? And I'm like, what? No, I'm sorry. This is garbage. How can Albert Einstein be so freaking stupid? Okay, and then I was thinking about it, and I'm like, oh, Albert Einstein wasn't being stupid. He was being very smart. Let me go back and show you some other things in history of physics that caused people a lot of grief when their theories got out. And the first one I talked about is Tesla. See, Tesla, everybody around before Tesla came along, they were all trying to figure out how to make DC work for everything. They thought that Edison had the right idea, yada, yada, yada. And it was developments by Tesla and Tesla's work in AC and development of the synchronous motor, the AC motor, that made AC practical. and it made it more practical than DC. Okay, but once this got out, and you had hundreds of companies with thousands of engineers all trying to jump on this new AC thing, well, they just basically pushed Tesla aside. After this, he made no relevant contribution to the development of AC after that point, because basically it was basically got away from him, is the way I'm using the term. He had to go off and do other weird things like trying to send high voltage through the air, yada, yada, yada. And it also happened again with the Wright brothers. The Wright brothers developed their theory of flight, I think it was 1902 or 1903, somewhere around there. And when it got out, okay, it couldn't go anywhere in the United States because they had all the patents on it. So basically the development of flight in the United States was retarded. Okay, so by the beginning of World War II, which was just World War I, which was only about 10 or 11 years later, at the beginning of the war, or during the war, all of these really cool airplanes came out of Europe. I mean, much more advanced than what the Wright brothers had, because they weren't being hamstrung by the Wright brothers' patents. The patents didn't apply to Europe. And so you have all kinds of a ecosystem of new airplanes from Italy, from France, from Germany, from England, and there's probably some other countries in here I don't recognize. And I love it. They have the little symbols for aircraft from the USA, but there is no airplanes from the USA listed on here, which is kind of funny. And so the point is, if you look at the beginning of the war, we only had a very crude airplane that looked somewhat like this. Which was all that, as far as the Wright brothers got, because they spent all their years in court trying to protect their patent, and they didn't spend any time on aircraft development. Okay, but in Europe there was no restraint, so it was, balls to the walls, and that's where the great developments in aircraft technology came from. They got away from the warped wing, and they had ailerons, better engines, better this, better that, the whole 9 yards, and the competition just set off a great development, a very fast development in airplanes over a very short period of time. So essentially, the Wright brothers, after their thing got out, they made no relevant contribution to flight technology after getting it out the door. And I think that's where Albert Einstein was like, hey, you know what? I'm not going to let this happen to me. If all of these people, physicists working in quantum mechanics and all the other ridiculous fields out there, realize that they all violate the locality tell and they're gibberish, then you're going to have all these physicists looking around for something to do. And then there's going to be a lot of competition from the little bit of physics like what he's working on left, because he was trying to work on the unified field theory. And it's not in his best interest to have thousands upon thousands of physicists looking for something else to do. And so what he did is he changed it. Said, quantum mechanics is just not local. And they basically just castrated locality. So it doesn't mean anything to them anymore. It's useless, the way they recast locality. And he did that. It is the only reason I can't understand why he would be so stupid, because he wasn't stupid. He was keeping everybody else going down the wrong rabbit hole, keeping them out of his sandbox, so that he can come up with the unified field theory. Because he didn't like quantum mechanics. He's the one that said God doesn't play dice with the universe. So if he was openly against quantum mechanics, why is he trying to help them out by saying their stuff is okay? It's probably non-local, and that's okay. You can just keep going on. Don't worry about it. Okay, that's the only explanation I can come up with why they castrated the principle of locality, which now I call the locality tell. But I've made the locality tell a little bit more rigid. Okay, but that's enough history. Let's go back, and this is how I rationalize that Faraday's law is not very good. This is Faraday's law up here, and I have quotations in law because it's really not a law, it's just an empirical model. And the EMF is the voltage induced in a conductive loop of copper. Okay, and what this says is that the voltage induced is relative to the time rate of change of the number of flux lines. These little crosses represent flux lines going into the page. Okay, these are flux lines coming out of a magnet, and these are going around. So in other words, these aren't going into the page or out of the page. They're staying in the plane of the page. So the way we represent this in engineering, if flux lines are going into the page, you put a cross because it looks like the fins of an arrow. So if you have flux lines coming out of the page, you just use a dot or a point to represent flux lines coming out of the page. And so that's how we represent flux lines in a two-dimensional medium for demonstration purposes. Okay, so what this says is that all of a sudden, if another flux line appears inside this loop, that's going to generate an EMF for a very short period of time. Okay, now this is where I have the problem. Well, wait a minute. So, in other words, if a new flux line appears over here, well, how does that affect the wire over here? It's not in the same location as the wire. This violates the locality tell. And here's the other problem that really pisses me off. This EMF, the voltage induced in the loop, is the net voltage induced in the loop. You don't know where the voltage is induced. So this violates the ambiguity tell, which is the 17th rule of acquisition. Nature is not ambiguous. If you have an electromagnetic field change, you should be able to show very precisely where in the wire the voltage is generated. But this model does not do that. Okay, now the question is, what if the change in flux appears outside the wire? Oh, well, then it does absolutely nothing. Isn't that making you go like, well, what? How is it when it's inside the wire it does something, but when it's outside the wire it does nothing? I'm sorry. When it's inside the wire it does something, but when it's outside the wire it does nothing. I mean, how does the wire know if the flux line is on the inside or the outside? I mean, because the wire is reacting to it, so something has got to be communicating to the wire that this change in flux was over here rather than over here. And so this almost sounds like the wire has to be smart and observe the magnetic field around it, which would violate the sentiency tell. Because there's no way the information, if the flux line is in or out, can be noticed by the wire, which is sitting here. Okay, but what if the flux line appears right on top of the wire? Well, that's another ambiguity, and we're just not going to get into that because that's a whole other discussion. Okay, there's nothing. It doesn't define what the inside of the wire is. Okay, is the inside of the wire the inside where the copper is, or does it go halfway through, or does it go all the way to the edge? There's nothing there for that. Okay, so Faraday's law violates the 25th rule of acquisition, which is the locality tell. This one has a classical equivalent because we just discussed it. 17th rule is the ambiguity tell. As far as I know, this is unique to Ethereal Mechanics. The 19th rule, the sentiency tell, as far as I knew, this is a common sense one, but they still have Lenz's law out there, which violates it. Lenz's law says that a wire will create a voltage equal and opposite to the amount of flux lines inside. In other words, Lenz's law works with Faraday's law. Okay, and there's where you get your sentiency tell. In other words, you have a model or theory that has to be sentient on where the field is. Okay, but for all of these, the ambiguity tell is the overarching rule of acquisition. Now, I was going to go through and give you a quick rundown of the rules of acquisition, but this video is getting long. The rules of acquisition are almost done. We have one or two that need to have revision. This is the mitigation of, this is what the ambiguity tell tells you about what an ambiguity means. An ambiguity doesn't necessarily mean that the theory is wrong. It could be wrong. That's one of the possibilities. The other theory is it's a special case of something more fundamental. Okay, so in other words, if you can try to find out where the underlying methodology of that model is, maybe you can find the more fundamental law of nature. Or it's just plain wrong. What I'll tell you is it's just plain wrong from my developments. Okay, now we're going to return to the PDX wire experiments that we discussed a couple of weeks back in the release of the new Electromagnetism V5 experimental results. Is this a play one? Okay, so if you recall, moving the magnet in motion was the problem. Okay, when it is the copper that moves, all the theories get the right answer. When it's the magnet that moves, only the new Electromagnetism V5 get the right answers. Okay, so here is the inverted wire experiment. The inverted wire experiment means that the wire moves and not the magnet. So it'll look something like this. If I bounce between, so here we're moving the loop instead of the magnet. And when we do that and we model this, so it's the magnetic field, all these magnetic field lines from the magnet are stationary. I'm not showing the magnetic field lines in the middle of the magnet just to keep this thing uncluttered. But in the middle of the magnet here, the field lines would be coming up out of the page. There would be dots here. Okay, so all the models that we were considering give good results when it is the wire that moves. Okay, and for the normal experiment where the magnet moves, okay, we had to go through this. We had to say, oh, all right, because from locality, we can only look at the individual charges of the magnet moving around, and only there can we get the determination what could possibly be used for magnetic field. And that's why we went this route. This was the equation we used for the magnetic field for the classical, corrected classical. Okay, this is a mistake up here. This would be the normal wire experiment. So now, the way we can correct the problem, okay, is if we keep the magnetic field moving with the magnet. That's what Einstein said. He said the magnetic field has to move with the magnet. And we're going to show you how that violates locality. But for now, let me just show you what the magnetic field moving with the magnet means. So in this case here, okay, this is not the inverted, this is the normal experiment where the magnet moves. See, as the magnet moves around, you can see how the magnetic field stays with the magnet. If we modeled the experiments this way, we would get the correct answers for classical theory here. Okay, so let me show you how this violates locality. So if we just look at a little arc of the magnet, okay, and we're just going to look at a few of the flux lines, because otherwise if I had all the flux lines here, this thing would get very, very busy. So we just have a few of the X's representing flux lines going into the page. So at one instant in time, the magnet's here. The next instant in time, the magnet's here. And this means that these flux lines that are out here have to follow the magnet as it rotates, which means, okay, that the farther away we get from the center of rotation, the faster that these flux lines are going to move. Now, according to the Biot-Savart model, there's no fundamental limit of how far away this theory can produce flux lines. So therefore, there's going to be a point where these flux lines way out here are starting to start moving faster than the speed of light. This violates rule of acquisition 21, the speed distance tell. I can see that the tiny little physicist brains are starting to issue steam and smoke, and what they're going to say is, well, but this is an inverse square law, and you're far enough away that's essentially going to go to zero before you hit the speed of light. Yeah, fair. Fair, but not really fair. Okay? So let me show you the worst problem. The bigger problem is, according to the Biot-Savart model, each differential, because remember, we can model this magnet very accurately as a ring of current. And so we're going to look at a little current element at the edge of the magnet, because this whole magnet can be modeled as a differential. It could cut it up into little differential pieces, and we can model the current moving through every single piece, and that, according to the Biot-Savart model, is all we need to have to be able to reassemble the magnetic field at any point in space. Okay, so what we're going to do right now is, since we have all the information in a single chart to make this violation of locality tell, to make it easier for you, we're just going to look at one differential tiny piece of charge moving at the tip of the magnet. Okay, and so according to locality, only the properties at the event location, so where this charge is moving, is the only place, only the information right here where the field is emitted is only the information you can have to determine what the field's going to do out here. And the only information you have here is the velocity of the charge. So the question is, if you only have this velocity, how do you know these three, there's infinite velocities of the charge in all these places. How can you tell what this velocity is going to be? How are you going to tell what this velocity is going to be? And how can you tell what this velocity is going to be? You only have your point, your location, and your velocity. Well, you also have your acceleration, but you can't use that for this. Okay, but even worse than that, even if you can come up with an argument that says, well, you can use the acceleration to kind of predict what these accelerations are going to be, the problem here is the Biot-Savart model only provides the flux density. In other words, the density of field lines. It does not provide flux velocity, nor does it provide locations of the specific field lines. If you had the specific locations, you could probably work out their velocities as they move. But there's no such information, nowhere from any of the information here that you could determine the velocity at the flux at any given distance from the point of emission. That information is not there, and that's a violation of locality. In other words, you do not have the information to be able to say these flux lines move faster the farther away you get from the point of emission. Okay, the only way you could do this is you need the information from another point somewhere in the magnet reference frame. Okay, so in other words, if you knew if your point charge up here that's moving knew where the center of rotation is, well then, knowing the center of rotation that you're rotating about, you could easily compute the flux velocities at all the different distances from the center of rotation. But you don't even need that. As long as you have another point within the magnet, you could do that. Because if you had a point anywhere in the magnet, you pick a point anywhere in the magnet and you could triangulate the distances to these points. I'm not going to get into how to do that, but that should be pretty obvious to people that do this for a living. And so there you have a lot of different problems. First of all, you need information from a point that doesn't exist in the location of the point of emission. That's a violation of the locality tell. And because you can use any point in the magnet reference frame, well, now you have an ambiguous model. Which point do you use? How do you know which one to use? If you can use any of them, if you can even use a point that's not even on a piece of matter. That's just as long as it's part of the reference frame, which is an imaginary object, an imaginary construct, then you can still recreate and get the right answers. But that doesn't exist. Okay, so now you're violating the ambiguity tell. And worst of all, this point has to know, if in order to be able to recreate these velocities, and not just these, it's all the velocities from all the points all the way around, it needs to know to pick a point only from the magnet reference frame. And so that looks like it requires a little bit of sentiency. Okay, so I don't know if I've beaten up you physicists good enough right now, but there's no way that you can do this. This is highly illegal. And you don't have to worry about it, because I have the new Electromagnetism version 5, which is able to get the correct answers for the wire or the magnet moving versions of the experiment without violating locality. So I'm already done. You don't have to try to defend classical theory. Okay, and let me give you a good analogy to this. This is an analogy to what classical theory is saying. If you take the wake from a boat moving through the water, well, yeah, I mean, if you look at the wake coming off the boat as it moves from point A to point B, the point of the wake almost looks like it has the same location relative to, let's say the perpendicular axis of the boat. And it almost looks like the wake moves with the boat, just like it looks like the magnetic field moves with the magnet. So I can see how you can observe something and get screwed up. But the problem is, this is where it violates locality, because in order for the wake to stay with the boat, this point has to accelerate really fast to keep so that it has the same orientation with the boat. And the farther you get away, the farther that wake has to transition through space in order to keep up with the boat as it rotates. And you can see that's clearly not how water waves work on the wake of a boat. In fact, this isn't even correct, because this point doesn't actually stay with the boat. That's an illusion. It's an illusion that this wake, this V, stays with the boat. Because what's really happening is, when the point of the boat's here, that's when this purple point's really emitted, and it emits and it moves linearly away from the point of emission, such that when the boat moves to here, it'll line up with the perpendicular of the boat. And as the boat moves to here, this point's going to move off from the point of emission, because the emission point was here, and moving away radially from the point of emission. And so because we know the point of emission, and we know the velocity of the propagation, we can detect where this energy is going to be. As a matter of fact, the energy from this point goes off actually in all directions. It just adds up like this. It's pretty cool how that works. It's very simple finite element modeling. You can just treat it as a whole bunch of concentric rings coming from the point of emission. In other words, as this point of the boat moves through waters, you can just plot concentric rings from that point. And when they add up, they'll add up as a wavefront like this, or a series of wavefronts like this. But now when the boat goes around a corner, okay, again, here's the point of emission. When the tip of the boat hits this point, that's where the emission starts. Then when the boat moves off to this much, then the propagation of the wave moves out. And so at that point, when the boat tip is here, that's when this propagation hits the perpendicular line. And then when this boat keeps going around the corner, this point just keeps going off perpendicularly. Okay, so you end up with a spiral effect, and this is incorrect. This is the correct way. I'm only showing the outside. I can't draw the inside one. I'm not that good of an artist here. Okay, and this is the proper way that a wake moves from a boat that's rotating. Okay, and that's the same problem. This is how you could confuse it. But then when you see the boat rotating around a point, you would realize, because you can actually see the wake where you can't see the magnetic field of a magnet. Okay, And that's the problem. A lot of this stuff we can't see, and so they have to assume what's going on underneath. And that's why we need these checks like the locality tell, which can tell us, nah, things can't move that way. I don't care if you get the right answers. That's not how things work. That's not how they, and so we cannot be using that to get the right answer, even if it gives us the right answer. It can mean this is what we call a false positive. This is a theory that gives us a good answer in spite of the fact it's fairy tale, that it can't possibly be true. I mean, you can use it if you need to, if you want to, but don't expect it to give you what the underlying theory of everything is. Okay, we need the truth at the upper levels in order to follow the rabbit hole down to the underlying theory of everything. Okay, this violates locality, this does not. Okay, please help considering, here's my begging and pleading section I promised you. Okay, I'm not going to read this again. I'm tired, I've got to get to work. Remember, our survival depends on it. Blah, blah, blah. So go look at my T3 and my T2 videos, and my T1 and my T3. I'll show you that T1, we have to hit 500 times the speed of light or we're going to be dead. And UN Sustainable Development requires us to get to a point where the human population could be sustained without digging anything out of the ground, just on what falls from the earth, from the sun. And my friends, without oil, oil allows us to grow 10 times as much food on an acre of land than without it, because of the pesticides, the fertilizers, the packaging, the refrigerants, the antibiotics, the preservatives. I might have said that already. Whatever. All of that allows food to be mass-produced on a scale that you couldn't do with sustainable farming practices. And allows us to feed a hell of a lot more people. Okay, so once the oil goes away, 90% of us have to go away. At least 90% is right now. Okay, so you can go to distinti.com, and I have a lot of my papers there for free. This has to be updated. Etherealmechanics.info is our blog, and if you go to etherealmechanics.com, that's our Patreon site. Please consider becoming a patron. I really appreciate it. I just got 10 new patrons in the last 2 weeks. We're over the 50 patron mark, which is an awesome. And I know my patrons, I will be getting back to you. I know I owe a lot of people to the upper tiers. I owe a lot of stuff, but I got to keep. I'm got to go down the rabbit holes first. You know, once you get the cavalry charge down the rabbit holes and get everything pieced out and stabilized, then we can start publishing everything to the tiers, and then later on to the general public. So thank you, everybody.